the conductance of a solution at a particular volume at particular volume at which salt or electrolyte. Salt are also called as electrolyte. Electrolyte undergo undergoes complete dissociation. Complete dissociation. Okay, is called as conductance at infinite dilution. Infinite dilution. What is the symbol? Symbol lambda 0 or lambda infinity. If you take molar conductance, mu 0 or mu infinity. Once again, see, with the help of diagram, we can understand the term conductance at infinite dilution. Once again, look at this, all of you. Take empty beaker and take 10 gram NaCl in it. 10 gram sodium chloride, solid salt, right? Without any water. We took 10 grams salt. Our assumption, we are assuming that for each 1 ml addition of water, 1 gram salt undergo dissociation and some free ions will generate and conduct current. Before addition of water, it is bad conductor of electricity. Why? Solid NaCl is a bad conductor. Why? There is no free ion. Free ions are not present, right? Before addition of water, its conductance is zero. Conductance is zero. What we are doing, we are adding volume stepwise, 1 ml, 2 ml like that. First add 1 ml water. In beaker, how much salt is there? 10 gram salt is there. When you add 1 ml water, out of 10 grams, 1 gram salt undergo dissociation, means dissolve in that 1 ml water. This is our assumption only, right? For 1 ml, 1 gram salt undergo dissociation, right? And some ions also generated or not. You are adding 1 ml water. Into that 1 ml water, salt will come and dissociate into ions. Ions are generated, so it conducts current. Right. Next, add another 1 ml water. Another 1 ml water. What happens? Uh, Another 1 gram salt undergo dissociation. And the number of ions increases. Conductance also increases. Now, how much amount of water you added? Now, 2 ml, 2 ml, right? Okay. Volume added, volume of water added, conductance. Mm, 1 ml, sorry, 1 ml. Assume for addition of 1 ml of water, some ions will generate and solution conducts current, and that value is some 5, approximate value 5 ohm inverse centimeter square mole inverse. 5 is some random value. Next, second time you added 1 ml, so total volume 2 ml. For 2 ml, ohm inverse centimeter square mole inverse. These are the units of molar conductance. Let us consider conductance is molar conductance. Now you tell me for 1 ml, what is the conductance value? 5 ohm inverse. For 2 ml, 10. For 10 and so on. Tell me for 10 how much? For 10 ml. 100. Okay, approximate value. Any value. But value should be increased. We have different conductance values, right? At 10 ml, what happens? You tell me. all the salt undergo dissociation or not? Because for 1 ml, 1 gram salt is undergoing dissociation. For 2 ml, 2 gram salt undergo dissociation, new ions will generate. For 10 ml, 10 gram salt undergo dissociation and ions will generate. After that, is there any salt to undergo dissociation? No. Here, all the salt underwent dissociation. So if you add more 1 ml water, nothing will happen because all the salt underwent dissociation, right? If you add 11 ml water, 12 ml, 50 ml, 100 ml, nothing will happen, right? I'm giving one value that is 100 ohm inverse centimeter square. This is conductance value at which volume? 10 ml. And remaining values, these 10 or 5, these are conductance values at a 2 ml, 1 ml. See, these are having some specific symbols. This value is represented as, tell me, this is represented as lambda 0 or lambda infinity or mu 0 or mu infinity. Conductance at infinite dilution. 100 is the conductance at infinite dilution. Why it is called infinite dilution? Because after 10 ml, there is no salt to undergo dissociation. This is the maximum conductance. This is maximum conductance. This volume is maximum volume where all the salt undergoing dissociation. So for 100, what is the symbol? Mu 0, mu infinity. Lambda 0, lambda infinity. What about symbol for this 10 value? What about symbol for that? 10 also conductance, right? Which symbol we have to give? Just lambda C or mu C. Lambda C or mu C. Here also lambda C or mu C. Conductance at a volume, normal volume. Conductance at infinite dilution, normal conductance. At any volume other than 10 ml. You can give the symbol lambda C mu C. Lambda infinity means conductance at infinite dilution, normal conductance and conductance at infinite dilution. Clear? Symbols. Okay for everyone. Infinity means at a particular volume all the salt underwent dissociation. Look at this. Alpha. Degree of dissociation alpha is equal to lambda C by lambda infinity. Degree of dissociation lambda C by lambda infinity or lambda 0. We can write like this also, lambda C by lambda infinity. What is lambda C? Conductance at any volume. Okay. Other than this 10 ml, like 2 ml, 1 ml, 3 ml, any volume. Infinity is at 10 ml. This is the conductance at a particular volume where all the salt undergoing dissociation. And remaining conductances can be represented by lambda C. Very important. If you fail to take the data, which is lambda C, which is lambda infinity, then you cannot get the questions. Clear? This is degree of dissociation. Direct questions will come. These two conductances will be given to you. Find out degree of dissociation. Right. In place of lambda C, we can take a mu C. Mu C by mu. Mu C by mu 0 or mu naught or mu C by mu infinity. Okay. Alpha is degree of dissociation in ionic equilibrium. We know about degree of dissociation. And you tell me what is the relationship between Ka and alpha? Ka and alpha. Acid dissociation constant Ka is equal to C alpha square. In electrochemistry, first year based problems will come. This is ionic equilibrium formula. Okay. We have questions like this linked to first year. This is first year formula. Acid dissociation constant. Ka is equal to C alpha square. How to get alpha? By using this formula. This data will be given to us. We have questions like this. Find out Ka dissociation constant. Clear? First of all, difference is clear for everyone. Conductance at infinite dilution and normal conductance. Normal conductance lambda C. Conductance at infinite dilution is lambda infinity. Clear? Right. Online students, you tell me. What is conductance at infinite dilution? Once again, please read the definition. Anybody? What is conductance at infinite dilution? Online students. Salt undergoes complete dissociation, right? What is the condition? Salt should undergo complete dissociation. Then only we call conductance as conductance at infinite dilution. In case of weak electrolyte, take acetic acid. Acetic acid. Take 10 molecules of acetic acid in a beaker. Just imagine empty beaker having 10 molecules of acetic acid. Add water continuously 1 ml, 1 ml, 1 ml, 1 ml, 1 ml. That is weak electrolyte. Do not undergo complete dissociation. Then how can we find conductance of weak electrolytes at infinite dilution? It is not possible to calculate conductance of weak electrolyte at infinite dilution. See the condition to find conductance at infinite dilution, the salt should undergo complete dissociation. But weak electrolytes do not undergo complete dissociation. Then how to find conductance of weak electrolytes at infinite dilution? We are going to start one law. Number of times came in the NEET and the JEE also. Kohlrausch law. I think you prepared for IP also. Kohlrausch law of independent migration of ions. Okay. Next concept, Kohlrausch law. So terminology is our next Kohlrausch law. First of all, complete the definition of Kohlrausch law. Let us complete definition of Kohlrausch law. After that, applications of Kohlrausch. Applications of Kohlrausch. See the definition of Kohlrausch law. Take sodium chloride solution, NaCl solution. Na positive, Cl negative, Na positive, Cl negative. This is NaCl solution. So this solution is having some conductance, right? If I ask you, what is the conductance of this solution? And imagine, sodium ion will conduct a current whose value is 2 ohm inverse centimeter square mole inverse. It's just imagination or our consideration, right? And chloride ions will conduct some 5 ohm inverse centimeter square mole inverse. Their conducting capacity. We are assuming. In a solution, we have sodium ions and chloride ions. What is the sodium ion conductance means one sodium ion carries how much current? 2 ohm inverse. One chloride ion will carry how much current? 5 ohm inverse. If I ask you one question, what is the conductance of this total solution? What you will do? You will add the conductances of all the ions, right? All the ions means 2 plus 2 because 2 ions are there. No? For each sodium, conductance is 2. 2 sodium ions are there. 2 plus 2, 4. 4 plus 5 and plus 5. Right. Total, we will add conductances of the ions. That is only called as Kohlrausch law. According to Kohlrausch law, the conductance of an electrolyte means NaCl. NaCl is the electrolyte. BaCl2 is the electrolyte. The conductance of electrolyte, it may be equivalent conductance or molar conductance at infinite dilution NaCl is equal to sum of the conductances of the individual ions. Conductance of sodium plus ion and conductance of Cl minus ion. Infinity or zero, both are same. This is only Kohlrausch law. According to Kohlrausch law, the conductance of an electrolyte at infinite dilution is the sum of the conductances of the individual ions. What is conductance of sodium chloride? Sum of the conductance of sodium ions plus sum of the conductances of chloride ions. The sum of the conductances of the individual ions. This is called as Kohlrausch law. Kohlrausch law. Hmm. Lambda infinity, lambda 0 represent conductance at a infinite dilution. We will discuss under applications. Applications of Kohlrausch law. That only. Today only we will complete that. First of all, definition is clear for everyone. Hmm? Color okay, comfortable. No. You tell me. What is the conductance of HCl at infinite dilution? Split this lambda infinity H plus lambda infinity. See, capital lambda for molecule, sorry, capital lambda for molecule, small lambda for ion, or sometimes they will give capital lambda also, nothing will happen. See, I took capital lambda and small lambda. Small lambda for ions in general. It is the original way to take. But in some books, they will give directly lambda. That is also correct only. Are you getting capital lambda, small lambda? Small lambda for ions to represent the conductance of ions. Capital lambda for molecule HCl. Okay. Okay. Whatever it may be the representation, it is clear first. What about this one? Or here mu we have to write. Okay, take there mu. This is also same. Mu HCl is equal to tell me mu mu infinity H plus and mu infinity Cl negative. Molar conductance. Molar conductance symbol is lambda m. You can take like this also. Lambda m HCl. Right? Now can you try this? H2SO. Observe carefully, all of you. Lambda H2SO4 at infinite dilution, mu H2SO4 at infinite dilution. Tell me how H2SO4 dissociates. H plus and 2 into mu H plus infinity plus mu SO4 minus 2 infinity. Correct? Why we are writing 2? Why we are writing 2 there? H2SO4 dissociates into H2SO4 dissociates into H plus and HSO4 minus H2SO4 dissociates into 2H plus SO4 minus 2. That's why we are writing 2. First, you should know the equations. Already you completed the splitting in ionic equilibrium. You are not new to this. If any coefficient is present, you have to write that coefficient. Okay, right? For molar conductance only, very important. For molar conductance only, we consider coefficients. While writing equivalent conductance, don't consider the coefficients. Gram equivalents, while writing gram equivalents in the stoichiometry, we do not consider coefficients. Here, directly write lambda infinity H plus ion plus lambda infinity Cl minus ions. Or you can take small lambda also, SO4 2 minus. This is the common mistake made by the students during the questions. What is a common mistake? See, without identifying the given conductance, equivalent conductance or molar conductance, some students will take coefficients. See, here we didn't take coefficients. For gram equivalents, we no need to take coefficients, right? Normality gram equivalent concept, no need to take coefficients. So for molarity, we have to take the coefficients. Clear? If I ask you to say molar conductance, then you have to take the coefficients. If I ask you to write equivalent conductance, then no need to take coefficients for equivalent conductance. Lambda H2SO4, mu H2SO4. Observe carefully, right? For equivalent conductances, we don't take coefficients. Just we wrote H plus only, but here we wrote 2 mu H plus. This is the common mistake. Okay, Kohlrausch law definition is clear, and how to split the salt or electrolyte and how to write the conductances. For molar conductances, take coefficients. For equivalent conductance, don't take coefficients. For example, MgCl2 is there. How to write molar conductance? Write once, all of you. For MgCl2, lambda infinity MgCl2. Tell me, lambda infinity 2 plus lambda infinity Cl. Don't take coefficient. But mu MgCl2, mu Mg plus 2 plus 2 Cl. For molar conductances, we take coefficients. For equivalent conductances, we do not take coefficients. HCl, that reflection not like activity. ఒక్కొక్క రోజు ఒక్కొక్కలా ఉంటుంది. Under Kohlrausch law, continuation, conductance of cation. Let us see the symbol for cation symbol C. Okay, C plus. Consider cation as C. C plus is directly proportional to ionic mobility. Ionic mobility. But first, in the first day or second class, I explained. Smaller ion moves fastly. It conducts more current. If mobility is more, conducting power is more. Conductance of cation C plus is directly proportional to ionic mobility. Let us consider ionic mobility as U positive. U positive represent ionic mobility. Ionic mobility. Conductance of ion depends on its mobility. If ion moves fastly, it conducts current fastly. It conducts more current. More current. If ion moves slowly, it conducts less current. Conductance of conductance of anion. Let us consider A negative. A minus is the anion. Is directly proportional to its ionic mobility. Ionic mobility, and the symbol is U negative. U negative. Any confusion in this? In direct relation in conductance is directly proportional to ionic mobility. Right. నువ్వు లేవా క్లాస్లో? ఆ రోజు లేవు అనుకుంటా. Conductance of cation is directly proportional to U plus. Conductance of anion is directly proportional to U minus. Remove proportionalities from this. Remove proportionality. C plus is equal to some K into U positive, some constant. Here also remove proportionality. A minus is equal to K into U negative. K into U negative. C plus is what? A conductance of cation. A minus is what? Conductance of anion. What is the conductance of electrolyte? Sum of the conductances of cation plus anion or not? Right? No. Equivalent conductance at infinite dilution of AC. AC is the salt form. Salt. Okay. Tell me, is equal to lambda infinity of A plus lambda infinity of C minus. C plus, sorry. C plus and A minus. AC is the salt. Salt dissociates into ions. Conductance of cation plus conductance of anion. This is only no Kohlrausch law. What is Kohlrausch law? At infinite dilution, the conductance of electrolyte is the sum of the conductances of ions, right? What is lambda? C plus? Sorry, C plus? C plus. Conductance of cation. A minus conductance of anion. Their sum is nothing but conductance of electrolyte. AC is the salt, like Na plus and Cl negative. Conductance of Na plus and Cl negative. NaCl is equal to Na plus and Cl negative. Now you know these values. What is C plus? K into U plus. Write that value. Lambda infinity AC is equal to, in place of lambda infinity C plus, you can write this value. K into U plus K into U minus. U minus. Then lambda infinity A into C is equal to, what is common? K is common. K into U plus and U minus. We have one value that will come later, K value. Just remember 96,500 coulombs. Why I explained this? We will get some questions. So we will get ionic mobilities. We will get ionic mobilities. Then we have to find conductance of the electrolytes. Okay, this is the procedure. Sometimes we will get ionic mobilities. Means we will get U plus and U negative values. Then we have to find conductance of the electrolyte. This is the formula. When you get ionic mobility, follow this. Conductance of electrolyte is equal to K into U plus and U minus. Ionic mobilities will be given to you. Okay. And K value is constant, 96,500, direct substitution. Add ionic mobilities and multiply with the constant, 96,500 coulombs, then we will get a conductance of the electrolyte when ionic mobilities are given to us. Okay. Coming to the applications of Kohlrausch law. Applications. Before that we discussed it is not possible to find conductance of electrolyte at infinite dilution because weak electrolyte do not undergo complete dissociation. Is it possible to find conductance of weak electrolyte at infinite dilution? No. Not possible. Why? Because weak electrolytes do not undergo complete dissociation. If electrolyte undergo complete dissociation, then we can find its conductivity at infinite dilution. But weak electrolytes do not undergo complete dissociation. Then how to find? By using Kohlrausch law. So applications of Kohlrausch law several times repeated in the NEET. Applications of Kohlrausch law. We can find conductance of weak electrolyte at infinite dilution. At infinite dilution. Same model question only repeated in the NEET. That is the advantage. Same data will be different, model is same. Numbers only are changing, right? But method is same, everything is same. Very easy. Example for weak electrolyte. Take acetic acid. See the procedure, how question will come. In the question, you will get a conductance data of three strong electrolytes. You no need to remember any data, you only will get the data. You will get three strong electrolytes. Okay. You have to find the conductance of fourth electrolyte. Fourth one will be weak electrolyte. One simple trick. You will get the conductance related to three electrolytes, three strong electrolytes. Next, you have to find the conductance of some X electrolyte. If you are going to calculate conductance of X electrolyte, that will be weak electrolyte only. Simple trick. You will get conductance values of three electrolytes, three strong electrolytes. Based on the conductances of the three strong electrolytes, you can find the conductance of weak electrolyte. They will give the question like this. X comma Y comma Z are the conductances of CH3CO, NaHCl and NaCl. Then find the conductance of acetic acid. Then acetic acid will be the weak electrolyte. What is the procedure? How to find? By taking one question, we can solve. Okay, I'll give you one question. With the question, we can understand the procedure. 250, 100, 150. Oh, minutes. Ohm inverse centimeter square, gram equivalent inverse, or conductances of CH3, COONA, HCl, NaCl respectively. Then find lambda infinity of acetic acid. This is the question. What is the conductance given to us? You tell me by seeing the units which conductance is given to us. Conductance values are given, na? In the last class I explained units also. Ohm inverse centimeter square mole inverse means which conductance that is. Gram equivalent inverse means which conductance that is. Equivalent conductance is given. Equivalent conductance. You have to calculate the equivalent conductance of acetic acid at weak at infinite dilution, right? See the procedure. First observe three strong electrolytes in which electrolyte common ion is not present. First, well, it's take acetic acid. Acetic acid CH3COO minus and Na plus. CH3COO minus. In this also CH3COO minus is present or not? Common ion is present or not? You are going to find a conductance of weak electrolyte. Now, what you have to do, observe the weak electrolyte. What are the ions present in the weak electrolyte? The ions are present or not in the strong electrolyte? Observe. CH3COO minus, CH3COO minus. Present or not? Yes, present. HCl, what is common ions? H plus. Here, H plus is there or not? There. CH3CO minus and H plus. Yes. HCl also having common ion. What about NaCl? What about NaCl? Is Na is present in this? No. Cl minus is present in this? No. Select the electrolyte which is not having common ion and subtract from the remaining. Add two electrolytes with common ion and subtract third electrolyte without common ion. Then you will get a conductance of weak electrolyte at infinite dilution. I'll explain. See this you can understand. We are going to calculate lambda infinity of acetic acid. What we are doing, you tell. I am adding conductance of CH3COONA plus HCl and subtracting conductance of NaCl. How to select the electrolyte which is going to be subtracted? Tell me, what is the trick? With common ion or without common ion? Without common. This is the trick. Remember this. Okay. Check. If we do like this expression will give acetic acid or not. Let us check. This is first problem. Na? Actually, you can substitute the values directly. See, you can substitute these values and you will get. But this is first problem. Let us check. If we do like this, if we add these two and subtract NaCl, we will get CH3COOH or not. Let us check. Tell me. How to split this? Lambda, lambda infinity of CH3, tell me, COO negative plus lambda infinity of Na plus. Ah. Next, lambda HCl, dissociate this, lambda infinity H plus lambda infinity Cl. What about this? Minus lambda infinity Na plus or minus? Minus. Here minus is there, no? Minus is there, total minus. So both will get minus. Minus A plus B, both will get minus or not? What are common? Cl minus Cl minus plus minus cancel. Na plus minus cancel. What about remaining? Lambda infinity of CH3COO negative plus lambda infinity of H plus. Add these two, what you will get? Yes, we are getting weak electrolyte. Yes or no? If you do like this, we are getting weak electrolyte. That is the logic. So what you have to do? Select three strong electrolytes. Select the strong electrolyte without common ion and subtract. Add two strong electrolytes with common ion. Subtract the third electrolyte without common ion. And proof is this. Now coming to the question. Actually, you no need to do all these things, right? You can substitute directly. Now tell me, what is CH3COONA conductance? And substitute the value. CH3COONA value is 250. 250 plus HCl value, HCl value 100 minus 150, 200. This is application of Kohlrausch law. Correct? This much easy problems are coming in the net. Out of 10, 8 questions are easy only. See, PVQs. Sometimes tough questions, but frequently easy questions only coming. This is important for IP or second year students. Long answer question with one tag problem. Problem. What is aldol condensation, Jubair? Product of aldol condensation? Product of aldol condensation? Hmm. Alpha beta unsaturated cause. Kerizaro reaction? Yeah. Did you prepare all the formulas? Second years, especially. Second year students. Santosh, you tell me. First formula and the conductance. Specific conductance K is equal to 1 by R into second day students. This is the final preparation for you for your NEET. Turn the pages, see. You do your work, okay? Specific conductance. And you will read this. Specific conductance K is equal to 1 by R into L by A. What is L by A? Santosh? L by A is having one particular name. L by A is still constant. R is the resistance. K is specific conductance, right? Next, molar conductance mu is equal to specific conductance into 1000 by molarity. Equivalent conductance lambda is equal to specific conductance into 1000 by normality. What is the relation between them? Molar conductance by equivalent conductance is equal to normality by molarity. And just now we completed what is alpha. Alpha is equal to lambda c by, tell me, lambda infinity. Lambda infinity. Just now I given this, right? And Kohlrausch law is general expression. Okay, let us start questions on this. This is first, not first part, one part. Okay, conductance part. After completing numericals, we will go to next part. What happens to conductance, equivalent conductance upon dilution? Increases or decreases? Equivalent conductance and concentration. What is the relation? Both are inversely. If you decrease the concentration, equivalent conductance increases. Molar conductance also. Molarity nothing but concentration term only, no? బాగా ఎగ్జామ్ చదివినట్టున్నావు నైట్ మరి రెస్ట్ తీసుకోపోయావా ఏముంది నోట్ అన్ ద క్వశ్చన్ దిస్ ఈస్ 25 is the previous year question of condition ఇది రాసావు కదా ఆల్రెడీ 23 5 question. Last year, let us see last year. Tough or easy? What you will feel if I give this question? Okay, first do 23rd, 2023, then 25. Now done question. First year students maintain notes for few problems, question and answer. First year, note down the question. Zubair, solve this. Zero to 1. Home inverse. Adiba, which conductance is given to you? Molar conductance is given to you. Okay. Resistance of the cell containing. Observe the values. Santoshni, which value, whose conductance is given to you? On what basis you are saying? Santoshni. Which conductance is given to you? Other students, other first years. Aisha, Surabhi, Ubid. Once I'll check the attendance. 19 students are attended. Very good. Aisha, Zui, Zuveria, Kirti, Ketra. Kirti, Ketra. కీర్తి చేయగలుగుతున్నావా నువ్వు ఆల్రెడీ అయింది కదా నీకు డూ డైరెక్ట్లీ కేత్రా కేత్రా యు ఆర్ లిజనింగ్ ఫస్ట్ టైం ఎలక్ట్రోకెమిస్ట్రీ ఆర్ డిడ్ యు లిజన్ ప్రీవియస్ కేత్రా కృతిక సమ్రా ఆల్సో మిస్బా ప్రాగ్నిక రాలా ప్రాగ్నిక వచ్చింది సారీ ఆశా జైనబ్ జైనబ్ ఆర్ యు గెటింగ్ జైనబ్ ప్రతిభ లోచన లోచన మీరు చేయండి డైరెక్ట్ గా ఓకే ఆశా జైనబ్ ఆర్ యు గెటింగ్ సురభి సురభి ఉన్నావా నువ్వు ఫస్ట్ నుంచి లేట్గా జాయిన్ అయినట్టున్నావు సురభి ఓకే ఫస్ట్ క్లాస్ విన్నావు కదా కండక్టెన్స్ ఫార్ములాస్ వన్స్ ఆల్ దీస్ ఫార్ములాస్ వీడియోస్ పెట్టాను చూడండి వినండి వినని వాళ్ళు ఓకేనా గ్రూప్ లో పెట్టాను మీకు కావాలంటే మీరు మళ్ళీ అడగండి రైట్ సెకండ్ ఇయర్ స్టూడెంట్స్ అండ్ లాంగ్ టర్మ్ స్టూడెంట్స్ సే ది ఆన్సర్ యూ కెన్ డూ డైరెక్ట్లీ యూ నో నీడ్ టు లిజన్ వన్ ప్రాబ్లమ్ ఆల్సో ఈవెన్ ఫస్ట్ ఇయర్స్ ఆయిషా సురభి ఉబైద్ షబీబా it's 23 model you only telling the depth it is tough or easy moderate by seeing the solution. First of all, I at the beginning only I said to you means conductance topic. Based on the units, we will select the type of conductance given to us. Ohm inverse centimeter inverse are the units for which conductance? Specific conductance. పోయిందా అయిపోయింది ఇక స్పెసిఫిక్ కండక్టెన్స్ స్పెసిఫిక్ కండక్టెన్స్ ఓమ్ ఇన్వర్స్ సెంటీమీటర్ ఇన్వర్స్ ఆర్ another unit in place of ohm inverse what we can write Siemens centimeter inverse because ohm inverse is equal to Siemens Simon is equal to 1 by ohm 1 by ohm or ohm inverse okay write the data 1.26 okay I'll check please wait K is equal to 0.021 okay and resistance what is symbol for resistance Santoshini IP రాసేసరికి మొత్తం బ్లాక్ అయిపోయింది మైండ్ రెసిస్టెన్స్ ఇస్ ఐపీ వెళ్ళిపోయింది మైండ్ లోకి అప్పుడే కొంచెం ఆబ్జెక్ట్ కూడా చూసుకోండి మీరు సెకండ్ ఇయర్ వాళ్ళు ఫార్ములా బట్ K is equal to 1 by R. Direct question. By R into L by. Substitute and tell me L by A. Cell constant is L by A. Priyanka, simplify and say the value. K value is 0.021. 1 by resistance, how much given? Here on 60. L by A. We have to find L by A. Send 60 this side. Very big simplification. 0.021 into 60. ఇది గుర్తుపెట్టుకోవచ్చు వినకపోయినా నో ప్రాబ్లం ఫార్ములాస్ అంటే ఒకసారి వింటే మళ్ళీ సెకండ్ టైం నీకు ఈజీ అవుతుంది జుబేర్ కుడ్ యూ ఏబుల్ టు సాల్వ్ ఫస్ట్ టైం హౌ మచ్ వాట్ ఈస్ ద వాల్యూ 1.26 correct very easy question right very easy question but at the time getting idea about the formula is important taking data is important data is easy only L by A units what is length value length units length units centimeter. A units is centimeter square. What you will get? Inverse. You substitute R units and these units, you will get L by A value. L by, she is asking about units. What are the units given to you in the question? L by A is equal to, let us write 0.021. What are the units for this value? 0.021. Ohm inverse or centimeter inverse, right? Ohm inverse, right? Ohm inverse, centimeter inverse into resistance ohm. Resistance value 60 ohm. Ohm inverse, ohm get cancelled. So what are the final units? Centimeter. Correct only, no? Okay. In the options they are given actually. I didn't give the options, no? Right. Now solve last year question. Priyanka, any doubt? Just we are writing units. Right data as easily cancel similar units. Options will be given to you like centimeter in the centimeter inverse only. Next, let's do this question 25. Actually, I didn't write the answer. Second question. You try. You can try all of you. 25 neat question. Molar conductance also represented as lambda subscript m or mu symbol. Of A 0.05 0.05 mole liter inverse. Mole liter. Solution of monobasic weak acid 90 Siemens centimeter square mole inverse. These are the units of molar conductance. Siemens means ohm inverse. Ohm inverse is centimeter square mole inverse. Its extent of dissociation will be. Its degree of dissociation will be. What is the symbol for degree of dissociation? Today's class only we completed. What is the symbol? Alpha. Alpha. And one data is given to you. This is last year question, easy only but bit lengthy question. 349 means cation conductance is given 349.6 Siemens centimeter square mole inverse and anion conductance 50.4 Siemens centimeter square mole inverse. First think, try second year especially. This is practice for you long term and second year students. Try uh, based on the previous formula. So what I wrote on the board before starting the numericals, if you use all that, you will get. Try. Use Kohlrausch law also. Okay, well. 96,500. No need to use that one. Ionic mobility is not mentioned na, here. If ionic mobility is given, then we use that. Ionic mobilities are not mentioned. Conductances are given directly for us. Cation conductance is given. Anion conductance is given. What is Kohlrausch law, Bhakti? Conductance of electrolyte is the sum of the conductances of the ions, individual ions. I am giving the hint here. We use Kohlrausch law. Kohlrausch law, right? Lochana, Zui, Zui, are you there? Zui, Lochana, Unnara, Lochana and Zui. Hey, answer Lochana and Zui. The molar conductance is given to us. Yeah, weak monobasic acid. That is only the Kohlrausch law. Kohlrausch law purpose is to find a weak electrolyte. Monobasic acid means it releases one H plus ion. Acetic acid. Acetic acid is weak acid and monobasic. Why? It releases one H plus ion. Monobasic weak acid means indirectly acetic acid is given. How to solve this question? Lambda m is given and concentration. Once look 0.225. Hmm. Correct answer, Losana. See once 0.05 data related to or belongs to dash. Which property, which parameter? What is molarity definition? Molarity definition. Second year. Number of moles present in 1 liter solution. Mole per liter means molarity. This is molarity. M is given. Molarity is given. Mole per liter. Mole per liter for which molarity? Molarity. M is given to us. See all of you. Stoichiometry basics also will come. All first year physical will come in the second year, right? The molar conductance of 0.05 mole liter inverse means molarity is equal to 0.05 molarity. Molar conductance of a solution is here ended. Data is ended. Statement is ended here. How much? Mu. This is molarity. Now write mu. Mu. 90 ohm inverse centimeter square mole inverse. Siemens nothing but ohm inverse only. How to find? What is the formula for alpha? Alpha formula. Lambda naught or lambda? Lambda c. Lambda c by lambda naught. How to find lambda naught? Or lambda infinity of what is the symbol for weak mono? Let us take it as a H. Weak monobasic acid symbol. It is the sum of the conductance of cation plus the add these two, then you will get a lambda infinity of weak electrolyte. Add these two. 349 plus 50. 349.6 plus 50.4. How much? 350 plus 50 approximately 400. And mu also, sorry, mu is given here. This is at any volume. This is at a infinite dilution. This is at a any value. I explained by taking table once. Lambda C or mu C. Mu is given now, mu C is this value 90. What is alpha? Alpha is equal to mu C by mu infinity. Here we calculated lambda. The symbol is given lambda, but Siemens in centimeter square mole inverse are the units of molar conductance only, na? Substitute in that and simplify. So time is physics class. 90 divided by 490 or 400, sorry. Simplify. Lambda m. That is also molar. 0.25. See, irrespective of the symbol, see the units first. This representation is okay. Anyway, in any way you can take, but units are important. If ohm inverse centimeter square mole inverse is present, this compulsory molar conductance only. If ohm inverse centimeter square gram equivalent inverse is present, this is compulsory gram equivalent inverse only. Okay, right. We will continue in the next class. Okay, any doubt, first year students? First years. Right. Second years. This final again. Electronics of proportions. When you write grand star, then percentages. In your college, grand star going. Today, today, tomorrow, and day after. Like one alternatives IP grand test. Okay, but you must already completed, no? So better to plan for all. What not something. Organic reading not other. Like you did not teach me all this. And in holidays also organic cover, no? Not informed. And you listen already first time, second read, that is revision. I listen. No. Actually, you have or just a second. You have access there. They move on already. You have access. At that time, organic we completed. In regular, your aims, organic is given or not plan. In the regular script, I completed. One time over second revision, I thought that is already later. That's why I didn't inform. I explain all organic from notes only. Actually, why did you inform? I don't want it. అందుకనే సార్ సార్ అన్న పాపం థ్యాంక్ యూ